Assalamualaikum and salam sejahtera. I hope everyone in the best of health. The title of my presentation today is Engineering Design Process EDP in STEM Education. Sometimes in the science classroom, we give our students a scenario or issue to discuss. Yeah, so there are many global issues that we are experiencing or in other countries. So we can use the examples like climate change, education, energy, food, health, pollution, poverty, urbanization, unemployment, water, and there are many issues that we can bring to the science classroom. And most of the global crises are being addressed in the Sustainable Development Goals by United Nations. So we as teachers, mostly we look at the quality education. Sometimes we ask our students to come up with innovation addressing clean water and sanitation, okay, or we are doing research on inequality for the goal number 10. So there are many issues that can be addressed looking at the Sustainable Development Goals. Alright, what's the difference of science and engineering? Okay, so we as science teachers or maths teachers, okay, we know that science is about knowing, while engineering is about doing. However, both scientists and engineers contribute to the world of human knowledge, even in different ways. For example, the civil engineers, they design road, bridge and building. The electrical engineers, they design electrical system like the oven, fridge. And the mechanical engineers, they design tools, engines and machines. Now let us look at the differences of scientific method and EDP. Okay, there are some similarities and differences. Okay, but why we want the teachers to integrate EDP in the classroom? Okay, let me give a brief overview of the differences. Okay, but I will discuss the steps in EDP later. Okay, the scientific method, mostly we ask our students to do scientific investigation. They can do experiment or they can even investigate a scenario doing inactivity. Okay, so we ask them to find questions. Okay, to find question, asking questions, and then ask them to do background research. Usually they can read the textbook or they can even search from the internet. Yeah, and then we ask them to construct a hypothesis. So it will involve some variables. Okay, and then we ask them to test the variables in the experiment. Is it working or not? Okay, and if is it working, we ask them to analyze the data and draw the conclusion. Okay, if it is not working, we ask them to troubleshoot and like probably looking at what's the problem. Okay, maybe there's a contamination or probably they have done something wrong. Okay, and okay, after they have come up with a conclusion, so they will communicate their results. Okay, if the results are not aligned with the facts or doesn't meet the hypothesis, they might have to go back and do it again. Okay, in EDP, of course, the similarity is, okay, the students define the problem, they do also background research, and then they specify requirement and they brainstorm, then develop the prototype, and then they test the prototype and they communicate their results. Okay, but in EDP, they will actually can go back to any stages to repeat. Why we want to integrate this EDP? Okay, so similar with scientific methods. We want our students to understand, okay, what they are doing. Yeah. Also, we want them to investigate and do some research. I would say the reasons why we ask our students to do scientific investigation or integrate EDP in the classroom, because we want all these reasons, because of these reasons, okay. We want our students to get to be engaged, to be involved, yeah, and we want them to work in team and to collaborate with their friends, and we are hoping that they can enhance their soft and humanistic skills, okay. And also we promote reflection. It's just that there are some differences in the stages of EDP, that the students have more advantages when they are doing the reflection. When we integrate STEM activities using EDP, EDP focuses on finding the optimal or the best solutions. Okay, often it involves in constructing prototypes. Okay, when the students develop this prototype, we actually promote critical thinking and problem solving skills. And then the students will realize that there are many ways to find solutions, okay, because they have to do brainstorming, and then they have to identify problems and they have to propose solutions, okay. And in EDP, it involves repetition of process in any stages, or what we call iteration, for them to improve the solutions that they have designed. In this presentation, I would like to discuss EDP framework by Massachusetts Department of Education, and there are 7 steps. Okay, the first one is identify the need or problem. The second step, research and research the need or problem. The third step, draw or sketch possible ideas or solutions for the problem. The fourth step, select the best possible solution. The fifth step, design and construct a prototype. The sixth step, test and evaluate the solution. And the final step, communicate the solutions. In the first step, identify the need or the problem. We ask our students to put themselves in other people's shoes, meaning that they have to imagine, okay, that they have this problem and how they want to solve the problem, okay. So we ask them to have empathy of other people's situation or problem, and we ask our students to come up with these questions. What is the need or the problem? Okay, who has the need or problem? Why is it important to solve and how to solve it? So these are the things for the students to start thinking before they come up with a scope of their research, or before they come up with something to solve the problem. In the second step, after they have decided the problem or after they have defined the problem, so they have to do some research. What is the need of the problem? Okay, and they can do literature review, they can read articles, they can, if let's say they want to come up with an innovation or invention, so they can read the articles looking at what have been published, the products that have been on in the market. They can do internet surfing, they can even interview some people, they can ask assistance from teachers or facilitators, yeah. And then when they do the readings, they can identify aspects to be avoided. Okay, for example, they want to design a solar powered car, so from the readings they know, okay, if they use this structure of solar panel, it can create problems, or they can get information about the costing, the safety, and there are many things that they will they will gather the information to help them to decide what's the need to, I mean, like, to come up with the solution. Okay, after the students have narrowed down their scope of work, okay, they will then specify the requirement. So they can draw or sketch possible solutions or ideas by brainstorming. Okay, and they will brainstorm their ideas as much as possible, try to come out as many solutions as possible, and then they will analyze the best solutions. So in the brainstorming activity, we have to tell our students that they have to capture as many ideas as they can. Okay, do not put down anyone. Okay, don't laugh, don't say that the ideas are silly, or don't actually demotivate their friends. Uh, we encourage wild ideas, yeah, because sometimes it can lead to innovative design. Please make sure that they do record all the suggestions, okay, and they can combine their ideas with others, and also they need to focus the topic. Okay, if they are going to do something about solar powered car, uh, they then discuss about solar cooker. Okay, so they have to be focused in finding the solutions. These are example of sketches or drawing that they can come up with. Okay, so they have to come up with at least a few uh, ideas, not just one. And then the next stage, they have to select the best possible solution or solutions. Okay, so they can compare their solutions to the requirement that best meet the needs. Okay, and they also have to discuss the costing, the time, the safety features. They have to have the skills and resources. That's why they have to work in team, and of course the product has to be I mean, like, original. Okay, for instance, when they want to design a solar powered car, they might discuss the cost of the solar panels, and then they have to consider the number of solar panels, and then the structure of solar panel that can meet best to store the energy. Okay, so they need to discuss pros and cons so that they can improve the design. This is an interesting stage where the students come up with a design of a prototype. Okay, it can be more than one prototype. So the prototype is an operating version of a solution. So usually the prototype is made from different materials of the final versions, and but they have the same function. Okay, a bit lesser standard, but and not as polished, but it is um, the development of a final solution so they can test whether it works or not. Okay, after they have designed a prototype, okay, so the prototype need to be tested, to be re-evaluated and improved. So this testing will allow them to see where is the problem, where's the issues of the design, so they can improve when they got the comments and feedback from other groups, or from facilitators, from teachers, or from targeted population, or they can even make like a mini exhibition where they call the expert to judge their design. Okay, so they have to make the improvement or changes before they settle on the final design. So from this stage, they can revisit any stages, any previous stages before, to improve the design. So that's what we call repetition or iteration of the process. So the final stage is for them to communicate the solutions. Okay, so it can be in the form of report, presentation, exhibition. Let's say they can also join science competition where they got the professional judgment about their product, and they can even put it in the display board like in school, or they can combine any methods when they document their solutions. Okay, and they can uh, do the copyright, or they can come up with a pattern to manufacture their product. Okay, and the documentation is very important because it will specify the quality standards of the product. Okay, so the engineers doing the same, so they are thoroughly documenting their solutions so that it can be manufactured and supported. I know many teachers are having problems to encourage the students to, like do even simple innovation at home. Okay, sometimes we ask them to record their work or record their activity at home, but it's kind of difficult. So in fact, we can actually ask our students to try out with a very simple innovation at home. We can even divide them into groups and give them some times to come up with the innovation. Of course, we need to explain the EDP steps, and it has to be, like the teacher has to monitor the students' work. So the examples of activity that we can ask our students to do at home is watercraft, solar sail, or solar water, clay boat, mini biodome, or any other activities that we can suggest our students. The video is very interesting, right? So they come up with several prototypes of the shoe design. Yeah, so we can give this kind of activity to the students and ask them to work in group and come up with some design. Right. What are the advantages of EDP in STEM classes or science class? It actually promotes out-of-the-box creative thinking and discussion among students, where they have to work collaboratively to plan, design, construct, and test a prototype or several prototypes uh, based on what they have learned, based on their prior knowledge and also new knowledge, and they have to demonstrate and test their prototypes. And also they have to improve their prototypes when they retest, yeah, and also they have to consider other people's comments and feedback, or if the prototypes is not fully working, they have to go back and redesign the prototype. Okay, and the students are expected to be able to identify and discuss the STEM concept that in their design or in their prototypes, yeah, and they are encouraged to find multiple imaginative, intuitive, and common sense solution, because there's no one right answer to any problem. Having said that, there are also disadvantages of EDP, yeah, because when you want to create a prototype, you need some funding or money, okay, and you need to buy materials, and of course you need human resources, okay, that's why you have to work in team. However, some students might not be interested to collaborate or involve in the project, so we teachers have to persuade them to be involved. And also some part of the activity, the students also need to have artistic skills, they have to be creative, and they have to like have critical thinking. Sometimes the problems with our students is that they don't want to think, okay, don't want to be creative, they don't even want to um, try. Okay, and the iteration or repetition process when they want to improve their design can be time consuming. Okay, and the results of EDP is not always a product. It can also be ideas, yeah, or like abstract solution. To conclude my presentation, I would like to suggest the teachers to try EDP in the classroom. Okay, because it has been proven that EDP is effective in the class, and because the students have the chance to repeat their work, and the process is open-ending, where we provide or suggest many feasible solutions to problems, and the students will also involve in a meaningful context when they apply science, maths, technology, and engineering elements in their work, and this process also stimulates students thinking. And when we integrate EDP in the classroom, yeah, we focus on the learner-centered, open-ended, and constructivist activities. We also introduce our students to pre-engineering skills, okay? Not really addressed in the curriculum, but in the science textbook, we do have the STEM activities, yeah? Um, but we want probably change to act like a scientist to act like an engineer. Okay, so we can ask our students to try that out, and we expose them to authentic engineering working environment, including team oriented projects. So we are hoping they might be interested to pursue their study in engineering. And uh, integrating EDP in the STEM or science classroom, we can also guide our students towards adaptive critical thinking, and to engage them into developing metacognitive skills.
The engineering design process is a tool that engineers use to guide their development of products and processes to make our dreams reality. Going through its steps helps engineers to empathize with the people who will use their finished products, learn from failure, and be creative problem solvers.
The engineering design process is iterative, meaning that engineers usually cycle through the process multiple times to get the best possible solution. The more times an engineering team iterates through the design cycle, the better the final solution will be.
The design process starts with empathy. Engineers need to clearly define the problem they're challenged to solve and the constraints they must work within. This often means communicating with clients or the group of people the solution is being designed for. Engineers also conduct background research on the problem, including finding experts who can give insight into technologies that might be adaptable to meet their needs.
After clearly defining the constraints, engineers open their minds by brainstorming. The goal in brainstorming is to come up with many creative solutions, not necessarily realistic ones. Only after coming up with many ideas do engineers focus on a promising solution and begin to plan the final product.
Engineers then build, test, and evaluate multiple prototypes. With each prototype, engineers learn from their failures and return to the earlier steps in the design process to ask how the product or process can be improved. Engineers help shape the future by using design thinking to solve tough problems. I can't wait to see how you use the engineering design process to make a world of difference.
I hope from the videos you have more insights and perspective on how to integrate EDP in your class. Here are some references that you can use to guide you to create activities with your students. I find it so good. The content in the science buddies or in tech engineering. There are so many examples that you can use in your class. Try it. Thank you so much for listening. If let's say you have any problems, please email me at jahan@usm.my. Have a good day, everyone.